Good morning, Chetan. Sangeeta, welcome, guys. Yes, good morning. And okay, so please confirm if you can hear me properly. And we are going to start this session. Today, we have a new topic to study. Good morning, Aisha. Yes, so guys, as you already know, Battle of Pole is going on. Yesterday, 6 p.m., we had started a new topic that is stereochemistry. Okay, what is the Battle of Poles once again? Pre-sessions completely made for practice. So yesterday we started the new topic stereochemistry. Watch the first session. It is there as a recording, and also you can attend more sessions. Just visit my profile and just visit the special classes. Okay, and you have to enroll. You have to register in each and every special class. These are free classes, so you have to register in all of them. We are having this session every day. Okay, every day we are doing this practice. Also, guys, informing you about the Unacademy Lite subscription, which is basically a little bit different from the Unacademy Plus and Iconic. How? Because in the Plus and Iconic, you get the educators, courses, and the mock test and everything you are getting over there. But this Lite subscription is only for those students who want to join for practice. So, 1 month subscription is 1500 rupees, 2 month subscription is 2100. So, this is basically only giving you access to the practice test series, question bank, and previous year question paper. All the mock test also by the Unacademy. Okay? Yes, very good morning. And guys, important piece of information that is tomorrow from 22nd of June, we are starting a new course. Now, this is a course, complete course on organic and inorganic chemistry. And tomorrow, 10:30 a.m., we start with the first session that will be based on organic reagents. First session on organic reagents tomorrow. Okay, 10:30 a.m. Right, and in this course you're going to get organic and inorganic chemistry. Along with this, we also have one more course which you are getting, the physical chemistry by Nurul sir. Okay, he'll be taking physical chemistry in the same batch course. You can just visit both of our profiles and just directly enroll in this course. Okay, I have also shared the link on the in different classes also. So just visit my profile on an academy and enroll in this course. This is a new plus course, and if you are not there on an academy plus and you are wanting to join, you can join today itself, and you can select any one of these following packages. All right, for the plus and iconic, this is the new batch that we are talking about, and this batch is for your December 2022 exam preparation. Matlab ki for those students who were waiting to start everything from new, this is for that. This is for those students. Okay, chalo. So yes, along with this, spectroscopy is going on. We are doing mass spectroscopy, and along with that, we are also doing a little bit of main group elements. Okay, chalo. So, important piece of information all provided. Now we are going to start a session on the carbohydrates. So, guys, following the carbohydrates, we are also going to talk about the amino acid. But first of all, let's discuss easy topic, carbohydrates. So the whole chapter of natural product, the whole unit of natural products has many things, okay, from your MSc syllabus, right? But we only focus on carbohydrate and amino acid because we are 100% sure that we will get a question from this topic. It is a small topic, right? And we 100% are going to get a question from this. So that's why we must not skip this carbohydrate and amino acid topic. Okay? Chalo. So let's start discussing. First thing, guys, let's classify. All right. In all the exams, in the TIFR, in the GATE and CSIR net, in all the exams, you have questions from these topic. Okay. So first do the classification. Yes. Good morning once again. Okay. So first thing is, guys, we are going to classify based on the type of units which are attached. And then we are going to see the structures. Yes. So monosaccharides, disaccharides, And polysaccharides. What is a saccharide? Basically, it is a sugar molecule. Yes, carbohydrates are also known as sugars, isn't it? Sometimes simple sugar, sometimes complex sugar. What is a sugar? Which is used to give you energy. Yes. Now, chalo. So we are going to classify, guys, what are the examples of monosaccharide, what are the examples of disaccharide and polysaccharide. Okay? Yes, anyone? What is an example of monosaccharide? Very, very simple. We have been talking about this all the time. Glucose, fructose, mannose, and arabinose, ribose, everything in which there is only one unit. Okay? Yes, aldoses and ketoses. Absolutely. So, yes, Ria, monosaccharides are those which are only having one unit of the carbohydrate molecule. So, you can classify them as further, we are going to classify them as aldoses and ketoses. What are those? Aldoses are those which are having the CHO unit, that is the aldehyde unit, and the ketoses are those which are going to have the ketone unit, isn't it? Yes. So this is going to be the aldose and the ketose like this. What about the disaccharide? Disaccharide means that you are going to have two units connected. Now one of those unit could be aldose and the other one could be ketose. ऐसा कोई example है where one of them is aldose and ketose? What does it give you? Sucrose. Absolutely. Because sucrose is made of glucose and fructose. And what about I example where two aldoses are being connected? Yes, maltose, lactose, absolutely. So two molecule of aldoses where they are getting connected, that is going to be your lactose. Lactose is made of glucose and galactose, and maltose, it is made of two units of glucose. Absolutely. Okay, so we have many different types of examples. Now, if we say we want to talk about polysaccharide, yes, polysaccharide means many different units of the carbohydrate unit. ठीक है मैं multiple है ये polymer है basically. So first of all, let's talk about starch, which is what you see most commonly. So guys, what is the starch made of? It is made of some units of amylose and amylopectin. Absolutely. Okay, then you have cellulose. All right, then you have cyclodextrin. यस, कभी कभार ना साइक्लोडेक्स्ट्रिन का सिमेट्री एलिमेंट भी आ जाता है. व्हाट इज द सिमेट्री एलिमेंट प्रेजेंट इन साइक्लोडेक्स्ट्रिन? ऑल राइट, वी विल सी द स्ट्रक्चर and you will have to say what is the symmetry element. Okay, this is very interesting. All right, so these are roughly classifying, this is how you classify the carbohydrates roughly. Okay, but there is one more type of classification, guys, that is the non-reducing and reducing sugar. What is that? One more type of classification, non-reducing and reducing sugar. What is that? So reducing sugars are those which can reduce tolerance reagent. Yes or no? Which can reduce the tolerance reagent, and also which can reduce Felling's solution. Felling's solution. Okay, and you know, guys, Felling solution and Benedict solution are just the same. Yes, and in the Felling solution you have the sodium potassium tartrate, and in the Benedict solution you just have the citrate. Okay, So when I say that it can reduce the Fehling solution or the Benedict solution, both of these are correct. Yes, all right. So इसका एक classification क्या है? Who will be reducing sugar? Who is going to reduce? Yes, all the molecules which have the free CHO, मतलब कि the CHO is free, it has not been involved in any glycosidic linkage. What is a glycosidic linkage? The one which connects two monomer units of the sugar. ठीक है? So all the monomers या फिर monosaccharides which have this free CHO group, they are going to be reducing sugar. Yes, aldoses or ketoses doesn't matter, दोनों सही है. Aldoses or ketoses, both of them are having this free CHO group. What about fructose, guys? Fructose में CHO नहीं होता, but with the with the tautomerism, it can generate a free CHO group. Also, we will discuss about that too, how that happens. Okay, by mutarotation. Okay, so all the monosaccharides are able to reduce the tolerance reagent, are able to reduce Fehling and the Benedict solution also. ठीक है? All right. And what about disaccharides? Yes. Yes. What about disaccharides? Disaccharides भी कर सकते हैं क्या? See, in the disaccharide molecules, you have to see that if you are having the alpha group free, that is the CHO group free, there is a possibility, okay, that the CHO is not involved in the glycosidic linkage, then it is possible. So except sucrose, in the disaccharides, except sucrose, the maltose, lactose, okay, so except sucrose, all of these are going to be reducing sugars. Lactose and maltose and cellobiose, all of these are reducing except sucrose. Why is that so? When you see the structure of sucrose, you will be able to say, ठीक है? Yes, absolutely. You will be able to say this. So, non-reducing sugar, as the name says, it is not going to reduce all of these. What is an example? Sucrose. Sucrose is an example, and many others, right? Many other bulkier carbohydrates, they are not going to reduce the solution, so they are not going to be non-reducing. First of all, guys, what we have to do is we have to see the structures and then we have to see how to remember them. Yes, we have to see the structures of carbohydrates, different monosaccharides and disaccharides. And are you supposed to remember all of the structures? No, not all, but few. Let's talk about those few. Okay, yes, let's talk about those few. So, first of all, we start from a very simple carbohydrate, that is your D-glyceraldehyde. And yes, don't tell me that you don't remember the nomenclature, the D and L. Yes, do you remember? Tell me the nomenclature D and L. Yes, the capital D and the capital L nomenclature. This is specifically for the carbohydrates. Yes, what is that? When the most oxidized group is on the top, the most oxidized group is on the top, and the OH is on the right hand side. OH is on the right hand side, you will say it is D. So this is what? D-glyceraldehyde. It is D-glyceraldehyde. Yes. Okay. All right. Okay, absolutely. Very, very simple. Now this is a aldo triose, isn't it? What is this? Aldo triose. What do I mean by this? Aldo matlab ki having the aldehyde group present over here. 1, 2, 3, 3 carbons. ठीक है? Yes. So aldotriose. Now, if we are increasing one more carbon, let's say if we are increasing one more carbon to it, क्या possibility रहेगी? Okay. So what do we have? Always remember the lower carbon must have the OH group on the right hand side, and that is when you say these are D sugars. All of these are D sugars. And when both the OH will be on the same side, you will say it is D erythrose. Both the OH are on the opposite side, you will say it is D triose. Just like the trio and the erythro molecule. Absolutely, very, very simple. And what are these guys? Dekho, there are four carbons over here, so I would say they are aldotetrols. Okay, very simple classification, aldotetrols. Now, I will be increasing one more carbon in the next slide. Yes, so we'll be increasing one more carbon in the erythros as well as in the trios. Let's say we are starting with D-erythros. So guys, you remember the structure, the lower part of D-erythros, okay? The lower part of D-erythros, how was it like? There were two carbons, CH2OH, the lower part was as it is. Yes? So now I have one more possibility. Let's say I'm adding one more carbon to it. So when the one more carbon becomes on the same side as the erythros only, I would call it D-ribose. Absolutely. When the OH is on the same side, then I'll call it D-ribose. And coming from D-erythros only, coming from D-erythros, this is what the erythros OH would look like. The down portion, the same thing. But here the OH is different. Now I would say D-arabinose. Okay? And then coming from the D-triose, coming from the D-triose, what was the structure of D-triose, guys? The down portion, how was it? Always remember OH will be, the lowest OH will be on the right hand side. Yes, this lowest OH, this one, always be on the right hand side. So triose was like this. This was the lower skeleton of the triose. Now what I can do is I can add one more carbon and I can keep the OH on this side, and then I can keep the OH on this side as well. What will be the names of these molecules? See, the OH over here look like X, isn't it? ये X जैसे लग रहे हैं ना? देखो, 1, 2, 3, they are all trans. So I will write xylose, D xylose, and here it is looking like L. See, isn't it looking like L? So I would write it D lysose. Okay, ऐसे याद रखो. The OH are looking like X over here. Yes, on the opposite side. So xylose. Here it is looking like L. So it is going to be D lysose. Very, very simple. Okay. Now from the D ribose, what are all of these? All of the ones that I've got over here, four isomers, these are all aldopentose sugar. These are all aldopentose, which means they are having aldehyde group and 1, 2, 3, 4, and 5 carbons. Aldopentose, absolutely. Okay. Moving onwards from here, guys, if you want to find out from the aldopentose, if you want to increase the one more CHOH group, because this is what we have been doing. CHO is as it is, the lower part is as it is. We are including one more group over here in the middle, CHOH group. If you increase one more, you are going to get the aldohexose. And how many different types of aldohexoses are there? As you can see, each possibility, ribose is going to give you two possibility, D-arabinose gives you two possibility, xylose two possibility, lysose two possibility. So total aldohexoses are 8. Absolutely. 8 aldohexoses you are going to get, but you won't remember all of them. So we are going to see a few. Okay. We are only going to see a few of it. And yes, do not burden yourself. So D-glucose you are going to first of all look at. Yes, D-glucose. D-glucose will have how many chiral carbons? How many chiral carbons in D-glucose? There are 4, isn't it? This is the structure of D-glucose. This is the structure of D-glucose. Okay? Absolutely. Now D-glucose and D-mannose. D-glucose and D-mannose, they are often known as epimers. From which position? They are known as epimers from the C2 position. What are C2 epimer? Epimer is also one kind of isomer only, just that you are swapping the places of H and OH. Okay? So D-glucose and D-mannose, they are C2 epimers. Absolutely, they are C2 epimers. What about D-galactose? What about D-galactose? CHO. So these are all aldohexoses. So all of them are supposed to have 4 chiral carbons. This is what you have. What is going to be D-galactose like? So D-galactose and D-glucose, they are going to be C4 epimer. D-galactose and D-glucose, they are going to be C4 epimer. So what is the C4 carbon? 1, 2, 3 and 4. Fourth position pe OH group will swap. So writing the molecule as it is, just like glucose, but on the fourth position I am swapping the places of D-galactose of the CH and OH like this. This is D-galactose. Very, very simple. Yes, this makes sense. So just remember this the structure of D-glucose. D-mannose is a C2 epimer and D-galactose is a C2 epimer. Now, one more important thing. This was all about the structure of the, the open chain structure. What about the closed chain structure? That is very, very important. Because in your exams, most of the times you are being asked the closed chain structure. Uska kya karenge? How to remember it? Yes. Then if you want to draw the closed chain structure, you have also got two different forms. One is a 5-membered ring and the other one is a 6-membered ring. Yes. The pyranose form and the furanose form. Yes or no? You have already discussed these points. What is a pyranose? What is a furanose? Isn't it? Yes. So first of all, guys, if you want to see, I am trying to make a pyranose form. That is a 6-membered ring. How do I do that? This CHO group is going to be this CHO group is going to be connected to, you are going to make a hemiacetal. Okay? So 1, 2, 3, 4, 5 and this OH is the sixth one. So when I draw this OH is as it is, this OH is also as it is, but yes, This OH has connected to this carbon. This is your hemiacetal molecule that you get. It is hemiacetal. Similarly, furanose form is a five-member ring system. When will the furanose form? When this OH on the C3 carbon, on the C4 carbon, 1, 2, 3, 4. Yes, that is going to give you, that is going to give you the furanose form. Let's check it out. This is it. This is how you get the furanose and the pyranose form. Now you have two different anomers in the hemiacetal form, that is the OH could be above and the OH could be below. But you are not going to try to draw this in the Howard projection. उसके through जाने की कोई ज़रूरत नहीं है. Just directly draw. Just directly draw for the alpha and the beta D glucose. Okay, let's say this is your glucose molecule. Okay, how are you going to draw? There will be two bonds over here. All right, two bonds over here. Okay, in this way, in this way, and in this way. This is your glucose molecule. ठीक है, let's try to draw this properly only with the substituents. ठीक है, only with the substituents. Okay, so first of all, when you see all of the OH, yes, all of the OH are equatorial. Let's say this is CH2OH, alright, the last one is going to be CH2OH. All of the OH groups are in the equatorial position. They are supposed to be trans. Yes, all the OH are trans. See, this OH is over here, opposite, opposite, opposite. So when all the OH are trans, we call it the beta D glucopyranose. We call it beta D glucopyranose. All the OH groups are equatorial, all of them are trans. We call them the beta D glucopyranose system. You see, and to identify, you have to start from the OH above. ठीक है, on the anomeric position, you have to start from the OH above in this way. Alright, we will see this in one more example. Just try to draw the, yeah, this five-member ring over here. So when you draw the pyranose, furanose form, guys, you can draw it in the five-member ring because in your exam it is usually asked in this way only. Okay, you are not going to get a six-member ring or the representation like that, so you can just draw it in this way. Let's say this is your oxygen. This oxygen right over here. So to one end of the oxygen, you have this free OH group. Let's say it is right over here. The OH could be below and the CH2OH could be above. Okay, to this carbon to which this oxygen is connected, you have, alright, just a second. Okay, in this way, this is your oxygen which is connected, and to this carbon, that is your anomeric carbon. Let's say I am having the OH below and the hydrogen is above, for example. So if this OH is below, let's say I am keeping this OH on the same side. The other one is trans, this one is trans, okay, and the other one would be as it is. There's a hydrogen connected onto this carbon, and this carbon is going to be still as it is. So this is a CHOH and CH2OH like this. Alright, 1, 2, 3, 4, and 5, five-member ring in this way. Okay. So usually this is how you write all the forms, all the different forms. Now about the alpha and beta D-glucopyranose, very simple. Let's first start with the beta D glucopyranose. Very, very simple this is. Start with the OH above. This is above. The other one is below, it is trans. Once again trans, so equatorial. Once again trans, so equatorial. And this is CH2OH. This is also trans. So this is your beta D glucopyranose. When I say that this anomeric OH is the carbon where on the same carbon you have the oxygen in the ring, and on the same carbon you have one more free OH. Okay, so when this is possible, you can have two different anomers. You have the possibility of two different anomers. Everything remains the same. Okay, so in the molecule of alpha D glucopyranose, everything remains the same, just like beta D glucopyranose. Only this OH on the on the aromatic position, this is going to go down. Okay, beta के लिए it is going to be above, and axial के लिए it is going to be down. So first draw the beta isomer. ठीक है, पहले बीटा आइसोमर बनाओ, उसके बाद में अल्फा बनाओ, just by changing this anomeric OH. Similarly, now you have understood. Yes, OH axial हो गया है, yeah, yes. So now you have understood the beta D glucopyranose. From the same structure, I'm trying to draw the beta D, let's say mannose. Okay, let's say I'm trying to draw beta D mannose या फिर mannopyranose. You know these two are C2 epimer, yes or no? So this is carbon number 1, this is carbon number 2. Let's compare. Alright, so this OH is going to be above in this way. This is your beta D mannopyranose. क्या हुआ? C2 epimer है. Yes, it is the C2 epimer of the beta D glucopyranose. So only this OH group on the C2 has become above. This was below, it has become above. This is beta D mannose. Yeah, mannopyranose. And you can draw the alpha form, guys. Just keep this OH on the axial position, rest of the molecule as it is. फिर वो alpha D mannopyranose हो जाएगा. So I am directly going to write for the beta D galactopyranose. What is the relation between glucose and galactose? Which epimer are they? Yes, कौन से epimer है? Beta D glucopyranose and beta D galactopyranose. They are C4 epimer. Where's the C4? Absolutely. This one is C4. Rest of the molecule will be as it is with respect to glucose. Only the C4OH becomes axial. Yes, this is what you have. This is your beta D galactopyranose. Very, very simple. Okay, so this is how you are going to draw. Yes, this is how you're going to draw all the beta D glucose, beta D mannose, and galactose. Yes. Okay. Now let's talk about, guys, one more thing. मैंने बताया था सबसे पहले what is a reducing and a non-reducing sugar. We will also study more reactions of carbohydrate, but first let's do what is the tolerance reagent, what is the Benedict solution, how is it going to be working as a reducing agent, वो देखते हैं. So the Benedict's or the Tollens solution. Okay. First thing, copper 2 plus. Either you have a copper, Benedict solution citrate or, tartarate. It is the same thing. You are having a copper 2 plus solution, blue in color. Okay. What happens is when you are reacting this with CHOH whole N, you have a free CHO over here. तो ये किसका पैटर्न है गाइस? ऐसे तो एल्डिहाइड दिखते हैं ना, aldohexoses look like this. या फिर I can simply write aldoses, not aldohexoses. I can simply write aldoses. Yes, all the aldoses look like this. N could be anything. Okay, all right. So this is your aldoses. Now, even if I don't have aldose, let's say I have ketos. Okay, this is a ketose molecule. ठीक है? So any of those molecule aldoses or ketoses, when it is reacting with copper 2 plus, it is going to be oxidized. Oxidation products you are going to get. What are the oxidation products? We'll see. Along with that, Cu2O, which is brick red in color. Brick red product. Okay? Yes. So when the change of color happens from blue to brick red, then we say कि आपका जो sugar है, aldose or ketose or whatever, that is going to be a reducing sugar. Okay? So this is the reaction with Benedict's solution. All right. Does it make sense? Everyone, yes or no? Okay. Now let's look at the structures. मैंने क्या बोला था? All the monosaccharides are going to be reducing sugar, isn't it? So let's look at disaccharide and let's see कि monosaccharide जो सारे reducing है. Let's look at disaccharides. Okay, how they are not. Okay, one more thing, guys. How is this ketose going to be a reducing sugar? Yes, if you are being asked about this, कि इसके पास तो ketone group है, it does not have a free CHO. How is it going to work as a reducing agent? What will it do? It is going to take a proton from here. Yes, अगर ये proton ले लेता है, then it becomes like this. Yes, then it becomes like this. Now consider this as the enol system. So first of all, we had considered this one, this carbonyl, and this one as the enol. अभी दूसरे वाले enol को consider करो. Okay. Yes. This is what you have. This is how you have got the free CHO group also from the ketoses. Okay. It is possible since you are having two hydrogens over here. Okay. Yes. Chalo. So we move onwards and we see the structures of different molecules. Okay. What are the different molecules? Let's see. We have different disaccharides, guys. We have plenty of reactions of monosaccharides to be studied. वो next session में करेंगे. Today we see the structure of disaccharides. Okay. So first structure that we will look at is your sucrose molecule. Sucrose क्या है guys? It is a non-reducing sugar, isn't it? मतलब कि even if your ketone group is free, see I told you, even if this ketone group is free and the CH2OH is free, तब भी वो क्या करेगा, epimerization करके it is going to give you this free CHO group. लेकिन अगर free नहीं है तो let's say it is used up in bonding, some kind of bonding. So let's say I am saying you are having the structure of sucrose like this. Okay. If I say कि ये sucrose का unit है, 1 unit of sucrose, what is this carbohydrate monosaccharide? Is it your alpha D glucose? क्योंकि बीटा तो हो नहीं सकता, बीटा में all the OH were trans. Yes, so it is supposed to be alpha D glucopyranose क्योंकि both the OH are below over here, anomeric OH is below. ठीक है. So what we are doing is we are taking this OH and we are connecting this to, yes, and we are connecting this to the furanose form of the ketohexose. Ketohexose का furan sorry furanose form different है. ठीक है. Tongue twister. Okay. So yes, this is it. And if you are confused, how is this coming? Please see the fructose molecule. कैसा होता है fructose molecule? CH2OH and the rest of the molecule is same as glucose. Okay. You have 6 carbons. So 1, 2, 3, 4, and 5 and 6. ठीक है. ये रहा. Yes. This is your yes, furanose fructose molecule. What will happen now? You want to form a 5-membered ring. So 1, 2, 3, and 4. And this 5 oxygen. So this oxygen is going to connect over here. And from here you will see you have one CH2OH which is free. Okay. And the oxygen, the carbonyl oxygen, let's say I'm directly writing, this will become OH. Which one? This carbonyl oxygen. This is becoming OH. All right. And the remaining OH are as it is. ये रहा, ये connected. This is how you basically try to understand. So 1, 2, 3, 4, and fifth oxygen. This is what you have, and this oxygen, this carbon is your anomeric carbon. Why? Because this will only decide whether the OH is above or below. ठीक है. So let's say this is our anomeric carbon क्योंकि यहाँ से OH भी connected है, CH2OH भी connected है. Okay. And the rest of the molecule you can write like this. So I am assuming that this OH is below. मैंने इस molecule को ऐसे गिरा दिया. ठीक है. Assuming the OH is below, this is CH2OH. Alright, these 2 units I have drawn till now. Till now I have drawn only these 2 units. Okay. Then next is this OH will be on the same side. This OH is going to be on the opposite side. and the other is going to be one hydrogen, one CH2O. Okay, this is it. This is what you have. How you draw the structure of fructofuranose. This is fructose और fructose का furanose form है, मतलब 5 membered ring form है. So this is alpha D glucopyranose this side, and this is alpha D fructofuranose. Okay, how have we drawn this? Please see on the side once again. कैसे बनाया हमने? बहुत simple है. This is what you have. So this is one type of disaccharide. Now guys, when you don't have the free OH group, मतलब कि no free anomeric OH, no free anomeric OH, when the anomeric OH is not free, कहाँ पे है anomeric OH? So from the glucose side, this is your anomeric carbon, and from the fructose side, this is your anomeric carbon. Both of these groups, okay, they are connected in doing the glycosidic link formation. What is the glycosidic linkage? C1OC2. In the case of sucrose, it is C1OC2. All right, and that is why this linkage is known as glycosidic linkage. Okay, and that is why it is not going to, yes, it is not going to be working as a reducing sugar. ऐसे हम बोल सकते हैं non reducing sugar. Sucrose, only sucrose, non reducing sugar. Now let's also talk about the structure B of maltose. What did I tell you about maltose, guys? Yes, maltose is made of 2 units of alpha D glucopyranose. Okay, let's draw the alpha D glucopyranose. So guys, this is one easy way, and we are going to draw it directly. या फिर जिसमें नहीं बनाना हो तो you have already considered this structure. ये देखो, ये हमने सीख लिया बनाना. What is the alpha D pyranose is going to look like? ये देखो, you have already learned this, no? So why not you draw in this form only? Alpha is OH below. The rest of the molecules are going to be as it is. Yes, the rest of the molecule will be as it is. Now what happens is, you are supposed to connect this to one more molecule of D glucose. ठीक है, कैसे करेंगे connect? Let's see. Draw one more molecule of the D glucose, and that also, now this other molecule of D glucose, it could be anything. मतलब ये अल्फा भी हो सकता है, बीटा भी हो सकता है. So I am just writing a zigzag line that it could be above or below, doesn't matter. What are we going to be concerned with? This OH, मतलब कि the one which is pointing below. So maltose has the glycosidic linkage of C1OC4. Okay, it has the glycosidic linkage of C1OC4 unit. मतलब कि C1, मतलब C1 of the alpha D glucopyranose and the C4 of your simple D glucopyranose. ठीक है, if we remove them, let's say somehow we remove both of them, and we just want to create glycosidic linkage out of this. ये हो गया C1OC4. Okay, for the case of maltose. Now as I said, maltose is a reducing sugar. इट इज अ रिड्यूसिंग शुगर. कैसे पता रिड्यूसिंग शुगर है कि नहीं? बिकॉज द C1 एंड C4 आर यूज. नो, इसका C1 यूज हो गया कोई बात नहीं, बट इसका तो फ्री है. This OH is still free, and what can happen in the presence of a little bit of acid? This ring can open up. If this ring is going to open up, you will have a carbonyl like this. Yes or no? तो ये जो फ्री हमारे पास CHO ग्रुप है, यही तो चाहिए रिड्यूसिंग शुगर बनाने के लिए. एंड फॉर दैट यू रिक्वायर अ फ्री hemiacetal group also. Okay. So to get the free aldehydic group, you need the free hemiacetal group, which is going to be like this. So maltose is a reducing sugar. Very, very direct. Maltose is a reducing sugar. Similarly, you can draw the structures of telobiose and lactoses. So let me just give you an example. We are not going to draw the whole structure, but you will get the idea now. अब जो molecule है cellobiose. What is cellobiose basically? What is cellobiose, guys? Cellobiose na? It is made of two molecules. First, beta D glucopyranoside. Beta D glucopyranose. ठीक है? This plus D glucopyranose. In this way. Alright, and once again the linkage is C1O C4. What is the difference over here? पिछले question में, पिछले example में हमने क्या था? Alpha, that is this OH was below, and in the beta form the OH is going to be pointing upwards. Over here beta will be pointing. Just that, no other difference. Okay, this is going to be C1O C4 linkage. What about option D? अब देखो C4, whenever you see C4 is being linked, which means that the anomeric OH is free. In this molecule on the right hand side, anomeric OH is free. बस हमें तो यही देखना है. If the anomeric OH is free of any pyranose form, तो हम बोलेंगे it is reducing sugar. What about the last type? Lactose. Okay, lactose is made of beta D galactose. Okay, beta D galacto या फिर beta D galactopyranosyl plus D glucose. This is what the lactose is made of. Beta D galactopyranose and beta D glucose. Once again, C1OC4. So once again, guys, the anomeric OH is free. Okay. Yes, the anomeric OH is free, and lactose also is a reducing sugar. Okay, both of these are going to be valid. Yes, this is what we have done today. Very basic things about the carbohydrates. We have not studied something very huge, only the basic stuff we have talked about in today's session. So we are going to continue the same in the next session. Next session में हम क्या करेंगे? We are going to do the reactions. ठीक है? We are going to do the reactions of carbohydrates. Plenty of different reaction per iodate oxidation, osazone formation, right? And yes, many important ones: whole degradation, rough degradation, everything that we are going to do in the next session. This was just an introductory session, all of you. Once again, informing everyone कि जो नया course है, that is one new course is starting from tomorrow, 22nd of June. Now this course is based on organic and inorganic chemistry, and tomorrow we are starting with the topic organic reagents 10:30 in the plus classes. So if you have not already enrolled, please do इसमें enroll भी कर लो, और अगर आपने plus join नहीं किया है तो join कर लो guys using this code. Okay, Jagriti S Live. And now I'm going to see you all on Saturday. The next session will be on Saturday on YouTube. Okay, chalo. All right. Bye everyone. Take care of yourself.